Have you ever looked up at sunset and seen a single star that outshines all the others? That's not a star, it's Venus, the brightest planet in our sky. From far away, it looks calm and beautiful. Up close, it's a world where metal can melt, the air can crush a submarine, and the sun rises in the west. Today on Mithra Centauri, we're diving into the most dramatic planet next door. Venus is the second planet from the Sun, and it reflects sunlight incredibly well. Its thick cloud blanket acts like a mirror, bouncing light back into space. That's why you can see it as the evening star after sunset, or the morning star before sunrise. Even in a city with light pollution, Venus pops. But those pretty clouds, they're not fluffy water vapor like on Earth. They're made of sulfuric acid droplets, highly reflective and extremely unfriendly to life as we know it. People call Venus Earth's twin because it's almost the same size, mass, and overall composition. If you just looked at the numbers, you'd think, great, another Earth. But the surface tells a different story. Venus is slightly smaller than Earth, but not by much. It has a rocky surface with mountains, plains, and volcanoes. And yet, it's the hottest, most crushing place on any rocky planet in our solar system. It's like meeting someone who looks just like you, but likes to live inside a volcano sauna while wearing a car on their chest. At the ground, Venus's atmosphere is thick, about 90+ times the pressure at Earth's surface. Imagine diving nearly a kilometer underwater and feeling that weight on every square centimeter of your body. That's what standing on Venus would be like. Space probes that land there don't last long. Their electronics and metal shells are pushed to the limit. And the air isn't friendly either. It's mostly carbon dioxide with clouds of sulfuric acid, no oxygen, no safe breeze, just a chemical pressure cooker. Thanks to a runaway greenhouse effect, the surface of Venus sits at around 465 degrees Celsius, about 870 degrees Fahrenheit. That's hotter than Mercury, even though Mercury is closer to the Sun. Why? Venus's thick CO2 atmosphere traps heat so efficiently that day or night, equator or pole, the temperature is extreme everywhere. On Venus, it's always oven time. So yes, lead can melt on Venus's surface. Your pizza? It would be charcoal in seconds. Up high, the clouds of Venus race around the planet in just a few days. Super rotation. Winds there can roar at jet plane speeds. But down on the ground, it's surprisingly slow and stagnant. The dense air moves like syrup. If you stood on the surface in your indestructible sci-fi suit, the landscape might look still, hazy, and yellowish with a dim sun trying to shine through thick clouds. Venus rotates the opposite way from most planets, including Earth. This is called retrograde rotation. If you could watch the sky from Venus's surface, the sun would rise in the west and set in the east. Even weirder, one Venus day, one full spin, takes about 243 Earth days. But Venus orbits the Sun in about 225 Earth days. That means the day is longer than the year. Time on Venus is wild. We can't see Venus's surface directly through the clouds, so spacecraft map it with radar. The radar pictures reveal huge lava plains, shield volcanoes, and strange pancake domes, broad, flat volcanic mounds. There are vast highlands like Ishtar Terra and Aphrodite Terra, and towering mountains such as Maxwell Montes, one of the tallest places on the planet. Is Venus active today? Evidence suggests it may still have volcanoes erupting or at least bubbling beneath the crust. If true, that means Venus isn't just a fossil world. It's alive with geology. Scientists have detected hints of lightning in the thick clouds, crackling through the sulfuric acid haze. At high elevations, some materials may act like a kind of metal frost, possibly due to metallic compounds that can vaporize at lower altitudes and recondense in cooler, higher terrain. And unlike Earth and Mars, Venus has no moons, just its lonely orbit and that thick, suffocating sky. Early Venus may have had oceans or at least liquid water on its surface. But as the young sun brightened and greenhouse gases built up, temperatures rose. Water evaporated into the air. Water vapor is itself a powerful greenhouse gas. So things got even hotter. Over time, the upper atmosphere broke water apart and lighter hydrogen escaped to space. With water gone, carbon dioxide took over. The result, a runaway greenhouse that never ended. Venus turned from maybe blue to permanently glowing orange. This story matters for us too. Venus is a warning that climate can shift a planet into a completely different state if the feedback loops get out of control. We've actually landed on Venus briefly. The Soviet Venera landers in the 1970s and 80s survived for minutes to a couple of hours, sending back the first ever photos from the surface of another planet. Orbiters like Magellan used radar to map most of the surface in high detail, showing us those volcanic features and strange terrains. More recently, spacecraft have flown by or orbited to study the clouds, chemistry, and weather. The surface remains a brutal challenge. Electronics overheat, metals weaken, and the pressure punishes every bolt and wire. But there's a sweet spot, about 50 to 60 kilometers above the surface. The air pressure is close to Earth's at sea level, and temperatures can be room-like. That's why scientists have dreamed about floating balloons or airships in Venus's upper atmosphere. Cloud cities for science. The catch, the acidic environment. Any hardware would need serious protection. Venus shows us that two planets can start out similar and end up completely different. Same neighborhood, same size, totally different destinies. By studying Venus, we learn how greenhouse effects can spiral, how volcanism reshapes a planet, how atmospheres evolve, lose water, and change over time, and where to look for habitable conditions. Maybe not on the surface, but perhaps in the cloud layers for exotic chemistry. When we understand Venus, we understand Earth better too. We get a clearer picture of what keeps our world stable and what could push it off balance. From our streets at dusk, Venus looks peaceful. But now you know the truth. Beyond those shining clouds, there's a world of pressure, fire, and acid, a planet that rewrote the rules of Earth-like, and that's exactly why it's worth exploring. If you enjoyed this deep dive, hit like and subscribe to Mithra Centauri. Got questions about Venus? Want me to cover another cosmic mystery, black holes, alien oceans, time dilation, or the birth of stars? Drop your questions and video ideas in the comments. Thanks for watching, and I'll see you in the next one.